Yes, ma'am.
Yeah, okay, thank you. Um, so today we are going to discuss about fourth module in your machine learning syllabus, that is about parameter estimation and detailed concepts of SVM classifier. So we are going to discuss about parameter estimation in forenoon session and about SVM classifiers in afternoon session. Let me share my PPT first. Is my PPT is visible to all?
Yes.
Okay, thank you.
Yes, ma'am.
Okay. So first of all, what is parameter estimation? It is actually one of the core concepts in machine learning. So the goal of parameter estimation is what is you have to determine the values of module parameters uh, for giving a prediction of a given data set. What data set you have taken, so based on that data set you will be giving some predictions using some predictive analysis, right? So for that, how you are going to determine your model parameters, that is parameter estimation. So these are one of the parts of model structure, and these are well optimized to minimize the model prediction and actual data's differences. So you need to understand that there will be a difference for sure what you are predicting using your data set and what is your actual data set. So that difference will be minimized while you are optimizing your technique based on parameter estimation. So, same, this is the actual definition. So, it involves in determining the values of parameters of a distribution or a model that best describes the observed data. It means, for example, if you are having a marks of the students, you are taking a mean value or a average value like that. The same simple thing you are doing in your Excel. So, the same thing you're going to apply it for your predicting algorithms, that is ML algorithms. What is the purpose of going for parameter estimation essence? Um, if any algorithm you are working with, you are need to create an accurate statistical analysis for your machine learning models. It means that suppose you are creating a CNN classifier, you have to train that classifier based on your inputs, and you have to train and train for getting optimized results, right? So that you will be analyzing that model how it is going on working. So that is the parameter estimation, that is the main purpose here. So it can be used across the fields like predictive models or a prompt engineering is since you will be asking a question to your model, that model will be answering you the answers with a, based on understanding of that questions. And in economics, to fine tuning the models, that means that in share markets they will be using many predictive models for predicting the future shares, right? So that is based on parameter estimation. In the main thing is to improve the optimization of your prediction models. We are going for parameter estimation. So why it is important? So the first thing is accuracy. It means that if you are doing your parameter estimation in a very well manner, then your model will be more reliable with accurate results. So the second thing is generalization. It means that while using a parameter estimation, you will be achieving a high generalizations of your models. It means that you will be allowing your models to apply effectively on unlabeled data. That is, unseen data is unlabeled data. So that is a generalization. So what is an application of it? If you are using a decision making algorithms or a predictive analysis, this parameter estimation is forming a root cause for these algorithms. It means that it is considered to be a foundation for these predictive analysis and decision makings. So what are the types of estimation approaches essence? So the first one is frequentist approach and second one is Bayesian approach. So you have to think that whether I have to go for a frequentist or a Bayesian. It means first the frequentist is mainly focusing on maximizing the likelihood of the observed data without considering the prior information. It means this frequentist approach will not consider the prior information of your data, while the Bayesian approach will be considering the prior informations of your data set by considering the probability of occurrences here in Bayesian approach. So that's the main differences. My idea is to, if you are doing any researches, you have to do these parameter estimations. So for that, better go for a Bayesian approach for more accuracy and high optimization for your models. So what is the key differences? Frequentist is mainly depends on data, while the Bayesian approach, while using it uses the data and also the prior knowledge, means what will be happened before by using these kind of data. So it means that finding the probabilities between the future and past, like that. So it is better to go for a Bayesian method instead of going for a frequentist. So if you are working in a data science projects, so you have to think that you're going to be a Bayesian approach or you're going to be a frequentist. So the better approach is to go for a Bayesian only. So rather than frequentist, if you are dealing with a small data set, you can go for a frequentist. If you are dealing with a large amounts of data, you have to provide more accurate results. My approach, better you go for a Bayesian approach. So what are the basic principles we are going to see? So these are the basic principles of frequentist statistics. The first thing, it also will be finding the probability, but without the prior knowledge of your data. So it will be finding sampling methods or desampling, like that. It will be going on. So next, the parameters will be estimated using a parameter estimation techniques. And third thing, the testing will be going on based on the hypothesis classes. So the fourth thing, it will be bringing out what are the assumptions you have considered. By considering those assumptions, what are the limitations will possible to occur and what are the limitations have occurred before. You have to consider in these point of view. So the fifth thing is critics and alternatives. If the limitations occurs, so what alternative had to be done to reduce that limitations. So in these ways, the frequentist statistics will be going on. So the fourth thing is Bayesian approach. So Bayesian approach, the first and foremost thing, it will consider the prior distributions. So what has happened before. So the second thing, it has to consider the posterior distribution. If I have followed that, what will going to occur in my future. So it will be saying in both perspective, that is past and future, and according to that it will be predicting the present, that is a Markov chain Monte Carlo method. So the Bayesian approach is the basis MCMC, that is Markov chain Monte Carlo. So after these distribution predictions, then only it is going to select which model I have to work with. So after that, it will be taking a sensitive analysis of the working of the model, how you have trained the model, how you have got the output, like that it will be going on. So hope you have understand the difference between the frequentist statistics and Bayesian approach. So this is a general comparison of the Bayesian and frequentist. So Bayesian, it will be working both via online and also the offline. So it can able to work in the offline mode, that is in the background running also. But in a frequentist approach, it will only operate on the offline only. So what are the different types of KPI means? So it choose the conjugate families. It will be choosing the different sets. So KPI means key parameter interpretations. So when to stop the experiment. So if anything occurs, limitation occurs, when you have to stop this approach. So if there is any rules are set So according to those rules, only patient will work. Frequentist, it will be having a sample size of data designs like that. So based on that, this experiment will be getting stopped. When to get the analysis results? Uh, while you are going through a patient, you have to get the updated results during data collection itself. So this frequentist approach, once the data collection is done, only after finishing that, then and there only you will be going to take the analysis results. But in patient, by parallelly, it will be taking the results of your data, what you are doing and what is going on in like that. So, what is the granularity level of data? It is purely based on batch size. On frequent test, it is purely based on whole test period. It means that time consumption is less in Bayesian and frequent test time consumption is more. What are the multiple comparisons you can take? There are varieties of Bayesian, Naves bias, hierarchical Bayesian, or co-clustering Bayesian, agglomerative Bayesian, like that. Many types of Bayesian is available. So it works in a hierarchical manner, but in frequent test, it will be occurring in a narrow band manner. So that is technically we can call as bone Ferroni adjustment. So the next thing is support early stop and fast iteration. Yes, you can stop your patient, but this frequently you stop at the intermediate. So it has to complete the whole, and after that you can able to stop this approach. So what about the interpretation with the probability? Yes, it is purely based on probability of occurrences. So Bayesian will wholly support for the probabilities, where the frequenting approach will not support for the probabilities. So how can you predict the conclusions, Essence? Yes, you can predict the conclusions in an accurate manner of the patient. In what way you are working with the patient, it depends. So while in the frequent test, you cannot take an accurate predictive conclusions on the frequent test, but still they are following this approach for small data sets. So if you want to deal with the complex data sets, you better go for a Bayesian approach. So real world applications of the parameter estimations. Uh, in finance. Finance is in share markets, that is stock market predictions and risk modeling, risk assessments. In these cases, parameter estimation is considered as a core concept. And while in healthcare, for diagnosing a disease or detecting a disease, and what kind of treatment you can prefer for after diagnosing of the diseases. So in these things, this parameter estimation is carried out. So in NLPs, that is natural language processing. So NLPs is purely for transformations of your messages, that is text to text or text to speech, speech to text, audio to video, video to audio, like that. Bridging these any two kinds of this NLP is playing a major role. But in NLP, if you are doing with a sentiment analysis or language transition models, this parameter estimations plays a major role in estimating those models data. So these are the real world applications of the parameter estimations. As I said, how it is working on a stock market predictions. That is stock market predictions and risk modeling, I have said in finance. So this parameter estimation, what analyst will do in stock market prediction results. So based on the historical data of the previous shares, how it has been sold out for in past and in future, how it can be like that, they will be predicting this. So what kind of models they are using is they are using ARIMA and GARCH model frequently. ARIMA is auto-regressive integrated moving average model. GARCH is generalized auto-regressive conditional heteroscedasticity. Heteroscedasticity model is they have been using these two models, in what way they're helping with? It is helping to focus the market movements and volatility. It means that how the shares are going to sell, in what way their point of margin of increasing, whether it will increase or decrease, or whether it will lie on a line like that. They are going to predict using these kinds of models by if we adjust the parameters, whether we have able to achieve our goal or not. So all these analysis will be going on stock market. So in order to increase the shares. So, in risk modeling in share market, how it is going on, essence, um, every stock market uh, are facing a financial risk such as credit risk, market risk, and operational risk. For example, value at risk models, that is VAR model, is a very beautiful model. These models use this parameter estimations like calculating a correlation between the assets that are estimated to determine the potential loss in an investment portfolio. Here, this accurate parameter estimation in these models, it can able to achieve for best risk mitigation strategies and comply with the regulatory requirements. So second thing in healthcare, while parameter estimation is used to create very good predictive models that supports in diagnosing a disease in an accurate manner, and if it is diagnosed, what kind of treatment can be applied for a patient for further recovering. So here, these patient networks are often used as parameters that represent the probability of certain symptoms that given a disease. Uh, by using these parameter estimations, we can accurately estimate what kind of parameters can be devised by having the previous patient's data. So, and by having the previous patient's histories, so these healthcare providers can improve our diagnostic accuracies. So next thing is treatment effect estimation. It means a disease has been diagnosed. What kind of treatments can improve a patient from the disease? It means in clinical researchers, estimating the effect of treatment is very crucial because in present days, all the diseases has been diagnosed in a different manners. Same disease, but in a different manner. So we have to improve the accuracy of diagnosing. So for that, techniques such as casual inference and survival analysis, these are the two techniques. It purely depends upon a parameter estimation for diagnosing the diseases and for better treatment outcomes. By by using a parameter estimation, uh, if you are using a parameter estimation in an accurate manner, you can overcome the hazard ratios or a mean treatment effects. And by keeping these things, the researchers can make the data driven decisions regarding which treatments will be most effective, and which treatment, if we apply on a patient, whether he or she will get recovered from that or not. So for these betterment of the treatments in research fields, this parameter estimation is playing a crucial role for guiding the doctors in making a good decision on disease diagnosis. So the last thing is NLP. So NLP is mostly dealing with the sentimental analysis. It is an analysis model for estimating the parameters such as the language features, enabling them to classify a text by the sentiment. It means that sentimental analysis, there are three basic parameters. One is a positive, neutral, and negative. So positive essence, the results are more accurate. Negative means, so it also can be considered as a parameters, but if we go in this path, it will be giving the negative results. So that path is effectively diagnosed using this parameter estimations. And neutral is this or that positive. It can be positive or it can be negative. So models like SVM and logistic regressions, NN, DNN, CNN models, it uses the parameter estimations to adjust the weights assigned to the words or a phrases. So the beautiful example is ChatGPT or Google Gemini's or GitHub's AI is uses these parameter estimation. So based on the customer questions, it will be putting you the appropriate answers based on the user satisfactions. So what kind of language transition models are available presently? So as I said, GPT is one of the example, and BERT is also one of the example. Google Gemini or Google Colab, it is purely based for programming things. So understanding these types of concept and languages, so we have to improve the quality of translations by uh, keeping on putting questions for the GPT model for fine tuning that model. So by fine tuning the parameters through large data sets means we can asking the questions, the same question in hundreds of different phrases. So it means that those models are trained like that. So by keeping on asking the questions, it we have to check that whether the model is providing an appropriate answers if the questions is also changed like that. Suppose my friend is in my near, I can putting on questions on her. He or she will be answering continuously the same thing the GPT is doing. It can learn the linguistic structures and also provide an accurate translations across the different languages. You can ask them. Uh, by present, you can ask them in English or Tamil or any other languages. It means that this GPT is under upgradation. If a customer is asking the questions in any languages, the GPT has to answer them what language the customer is preferring. So that is going on. It actually supports a global communication and accessibility. So next thing is introduction to maximum likelihood estimation. So there are several parameter estimation techniques. So we are going to deal with the two types of techniques. One is MLE, that is maximum likelihood estimation, and MAP. So what does MLE means? Uh, it is dealing with a statistical method where the parameters are estimated by maximizing the likelihood functions. So this is the approach to find the parameters that making the observed data um, that must be most probable according to that model. For example, consider a linear regression model. The MLE method would find the weights that maximizing the probability of observations in the given data sets. So that is a very good example. So what is the principle this MLE is following up? What is the main principle essence? The core principle is to select the parameter values that maximize the likelihood of the observed data set, as I said before. So it means if you want to generate a sample from a population and we want to find the parameters that underlying a probability distribution means you have to find out the likelihood function by optimizations. This MLE provides the parameters that estimates the best explanations that observed data, making it one of the most widely used techniques. Um, as I said, in linear regression, which is playing a crucial role, this MLE. So, what is the likelihood function? How you can estimate it? It is purely based on probability of observing the given data and the present data. So, the first thing is L of theta is equal to P of x bar 0. That is, this theta is considered as a parameter. L of theta is a likelihood function. If you want to estimate the probability of, for example, take a coin, if you are tossing it, so what will be the probability of hits 1 by 2. So the likelihood function describes the probability of observed number of hits in a probability value. Suppose you are tossing a coin for 3 times. What is the probability of occurrences of hit maybe? So 3 by 3. It can be 3 by 3 or a 2 by 3 or 1 by 3. So the maximum probability is 3 by 3. That is probability is equal to 1. So this is a likelihood function if you are dealing with a reality model population with the sample data. So by keeping the sample data, you have to derive the likelihood function. So after deriving the model, you have to give the probability by dealing with the data samples. So the example likelihood function is defined like this. Why you want to maximize the likelihood? So there are major properties of MLE. The main three properties are it can be unbiased, and may not be or may be consistent, and there is no need of prior information in MLE is needed. So what is the purpose is, if you are maximizing your likelihood function, so it will help you to identify the parameter values in an optimized manner by explaining the observed data. So what can be the intuition will be? Intuition means it may happen or it may not happen. That means imagination of the results you are going to get. So suppose imagine you are going to fit a curve to a data points. So what will be the best fit line? It maximizes how closely it follows the actual points. So that is the beautiful intuition here. So this is the formula theta of MLE. It means that parameter of MLE, how it can be calculated. It depends upon the likelihood function, that is the probability of X depends upon the parameter. So you are taking the arguments of maximizing the function, that is maximizing the likelihood function by means of the parameters. By finding this, we can obtain the parameter estimation that makes the observed data more likely. So what are the steps in MLE calculations? So the first step, you have to define the likelihood function. So a likelihood function defining is purely based on the user perspective only. They can use the probability, that is Bayesian or frequency approach. So the second thing is take the derivative with respect to the parameter. By involving the parameter of the data sets, you have to derive a likelihood function with respect to it. So the third thing is set the derivative to zero. So initially you have to set your derivative to the zero, and after that only you have to solve your parameter based on your data sets, and you have to derive the theta cap MLE function for estimating the parameters in respects to the likelihood function. So, so the first one is binomial distribution. So, for example, imagine you are conducting an experiment that is pointers for n times. What will be your probability? 1 by n. So you will be estimating like this. So how many number of times you will be getting hertz, that you keep it as p. So based on the outcomes of flipping your coin, and k be the number of hertz on the observed out of n flips. So this is your example setup. For this, first step, I have to derive the likelihood function. So based on my binomial distribution, I'm deriving the likelihood function as p power k into 1 minus p to the power of n minus k. So k will be the heads and n will be the number of flips here. And p will be the probability of getting hits. So the second thing, you have to find out the value for maximizing the likelihood function. Here I'm going for logarithmic of the likelihood function. So, so the formula can be log of L of p equal to, so it can be. So then So this function, it can be for logarithmic of likelihood function with respect to the probability. You are taking a different distributions for logarithmic of likelihood functions. You will be deriving like this. So the second thing, you have to set your derivative is equal to 0. You have to solve your probability. So by keeping my derivative equal to 0, after that I'm getting like this. So by simplifying it, the probability is equal to k divided by n. So that is number of heads getting while flipping and total number of flips. So in case of normal distribution, you have to estimate the values such as uh, you have to estimate these two values for maximizing the likelihood of the observation of the data. So the same things. The first thing I have to set up my likelihood function. So by finding this likelihood function for a sample n data, it can be like this. So the second thing, I'm taking a logarithmic of likelihood for deriving. Uh, it means for maximizing my likelihood function, I'm taking the logarithmic. The function will be like this. After simplifying it, it means that for after simplifying, you will be taking the summation for this and n by 2 for this. So it can be simplified like this. So next thing, you have to maximize the likelihood. You have to set up these parameters like this, and after solving, you have to set up a 0 for a derivation. So after a final, my simple mean of data will be like this. So this is the way how the MLE works on estimating the sample mean of data. So after that derivation, after the simplification, your variance mean and mean can be like this, and variance is able to find like this. So after taking the logarithmic, how you can take the logarithmic for a likelihood? It means for simplification of a likelihood function, we have to go for a logarithmic function. It means by converting the products into sums. So if there are number of products, if you are converting into some product, sum, that is product into sum, you can take the logarithmic. If you're considering a large data set, you can go for this function. So what are the properties of MLEs? It is very consistent, and if you are using the MLE, it will be very efficient, and it is maximizes the likelihood function, and it cannot have a high variance if you are dealing with a small data, but it can be unbiased, so the variance cannot be decreased while using MLE. So mostly this MLE is commonly used whether no prior distribution is available. So this MLE is mostly with the frequency approach, not a Bayesian approach. So no, I have to use a Bayesian approach. Model will be what model in parameter estimation I can go for means you can go for this one, maximum posterior estimation. That is, you can, if you are using a Bayesian, you can go for a map. If you are using a frequentist, you can go for an MLE. What are the numerical methods applicable for MLE means gradient descent, Newton-Raphson, and these are the two methods. These two methods will be following uh, iterative approach only while dealing with the analytical set, but it will provide a NP hard analytical solutions while you are working in MLEs. What are the applications means? You can this MLE cannot solve directly, but it while using a maximizing function only, you can able to provide an accurate results. That too, it can operate in an offline mode only, as you are applying this parameter estimation for a frequentistic approach. So it will be going seamlessly with frequentistic approach only. So this is a gradient results. You will be designing like this. And Newton-Raphson means you will be going on calculating using the mathematical formulas by taking the functions on f dash of x. It means Newton-Raphson is generally a trial and error method only. So this is one example. So what are the limitations means ML is very sensitive. It will not be sensitive if you are dealing with small amount of data. If you are dealing with a large amount of data, this algorithm will be a sensitive one, and there will be a small sample bias will occur because the main property of a MLE is bias variance trade-off. It means that it generally deals with the inclusion of prior distributions like, so while you're including a prior distribution, it can reduce the variance. Keep it in your mind, it can reduce the variance, but it will not reduce the variance completely. Making, if you are going for a map, it considered to be less sensitive when compared to MLE. So how can we overcome these two properties means instead of by using a map technique or a Bayesian methods, you can overcome from of the limitations of MLE. So the next thing is maximum a posteriori estimations. Um, what is a map? It means it is a method that is used to estimate the parameters of a statistical model. What is it is means it is a method that estimates the parameters by maximizing a posterior probability of the parameters. So unlike an used we are derived in MLE, this incorporates the prior knowledge about the parameters, while the MLE will not take the prior knowledge. This will be considering the prior knowledge as like we are doing in the Bayesian networks. It mainly dealing with the Bayes theorem only. So the formula will be same as Bayes theorem. This is the probability of map estimations, whether theta is the number of parameters, and this is considered as a likelihood function here. So this is a likelihood function, and this is a posterior probability, this is a prior probability, and this is the marginal likelihood with respect to the data x. So how can you write your simplified formula that map function can be written as by finding the arguments of maximum functions of the probability of the likelihood function and the parameter estimations of the probability. Like this, you can write a map estimations. So what are the advantages of the MAP over MLE? It means that MLE is not dealing with the prior knowledge, whereas MAP is dealing with the prior knowledge as and we are doing in the Bayesian approach. So this is the main difference. So what are the key differences? Means that here you are maximizing the likelihood based on the probability of a theta parameters. So you will not consider the prior knowledge of the theta parameters. So this not consideration will leads to the overfitting in the presence of limitations of the data. So while in the map, by maximizing the likelihood project with respect to the Bayes network, it includes the prior information that will be helping in a regularization of the estimation processes, and thus overfitting problem can be overcome by the map. And if you are using with the less data means and prior knowledge is also already applicable means map is very well suitable parameter estimation technique, and you can get very good accurate results in that cases. So what is the role of prior knowledge in map estimation? So this prior knowledge, it plays the vital role as it is following the Bayesian approach. That Bayesian approach will not work without prior knowledge of the parameters. So it will be getting reflected in our knowledge about the parameters before observing the data, and this prior can represent the information obtained from the historical data, that is past working of your data sets, that is represented as prior knowledge here. In order to understand domain specific easily, you go for a map estimation. And map, what is the map formula? Since same thing, it will be dealing with the prior probability and how this probability is influencing the map estimate. This is the initial formula. How you are going to derive is it? What is an example? While you are flipping your coin, take the example as a flipping your coin. Uh, First one, in one occurrences, suppose you are flipping your coin for 3 times, you will be getting a 2 heads in the first occurrence. In second occurrence, you will be getting only 1 head. And in third occurrence, you will be getting 3 heads. And in fourth occurrence, you will not getting the 4 heads. So these historical data is considered here for estimating the actual probability of getting hits. So that is an example here. So next thing is bias variance decomposition. So why we are going for bias variance decomposition means it is a fundamental concept in the machine learning. Excuse me, in machine learning, and this statistics is help to understand and analyze the sources of an error in the predictive models, and this bias variance bias variance decomposition, it provides insights of how different sources of errors are contributing to the overall predictions errors. It means here you will be breaking down this bias, variance, and irreducible. How we are going to decomposing this kind of bias occurs. So, what does bias variance trade-off means? It is a bias variance trade-off. It is one of the property of MLE, and it can be overcome by map in dealing with the small data sets. So, as I said, it is a fundamental concept of machine learning and statistical modeling that describes the relationship between the simplification of a model and the model flexibility. Thus is bias. What is a bias means? Um, that errors on overly simplistic model is error, that is bias, and error introduced by overly complex models, that is variance. How you can trade off these two parameters like this, how you can decompose these two parameters. So what is bias and what is variance? I have said while dealing with a simplicity model, bias error, and while dealing with a complexity model, the error is known as the variance. So this bias will usually occur under fitting, and the variance usually occur in a overfitting strategy. So systematic error from incorrect assumptions. If your assumptions is incorrect, uh, bias, it refers to the that is introduced by incorrect assumptions made by the model, and it is also the difference between the expected and model output and the true output. So generally, high bias and low bias. There are two types of models are there. So high bias, when it will be occurring, means when underfitting occurs, high bias will occur. When overfitting occurs, low bias will be occurs. For example, for high bias means consider a linear model that you are going to apply on a data with non-linear relationship means that will be underfitting. Obviously, the model is not going to fit. So low bias means if you are dealing with a more complex model, but consider a deep neural network like that, but you have very small data, then the model will be considered as an overfitting for your data. So this is high bias and low bias complications. So what is the source and what are the impact that can be occurred and what are the examples? I have said high bias and low bias example, and here they have represented an example dealing with the linear regression models I have said that only. So this is a high bias situation and this is a low bias situation. So next thing, the variance. How you are understanding the variance. So it means variance, it is the measure that model sensitivities and small fluctuations in the training set it occurs means that is considered to be the variance. And high variance means if the model predictions vary widely in different training data sets means that is any random fluctuations in training data set that occurs is refers to the high variance. So there are two variance can occur, same as a bias, high variance, low variance. High variance is for overfitting and low variance is for underfitting models, same as like bias. So the next thing is uh, noise. What is a noise means? Irreducible error in the data. That is, there are types of noises we have dealt. I think in module one, I have represented types of noises available. So it is the irreducible error in the data that are inherited and cannot be modeled or predicted. If noises are occurring in the data while putting into a model, better use the data cleaning technique for cleaning or reducing the noises while proceeding it. But if there is a noise in the data you are giving into a model, no model can eliminate that noises. Before inputting a data into a model, better check with the data cleaning techniques or for finding the noises or reducing the noises. After that, you put into a model to for getting a good optimization for your model. So total error decomposition that can be calculated as bias squared plus variance plus noise. So this is the total error decomposition. By predicting it, you can able to overcome from underfitting or overfitting situations. How you can manage a bias variance trade-off. So there is often a trade-off between the bias and variance. There can be situations like high bias, low variance. This is the first situation. And second situation can be low bias, high variance. And third situation is optimal point, that is, it is purely dealing with the noise. How you can minimize these things. So first thing is bias variance decomposition formula you have to use, and you have to calculate how much bias and variance are going to you are going to face while you're inputting your input into your model. So this is very critical one for understanding the model's performance and tuning it for better generalization. So this is the formula. So total is equal to bias square plus variance plus noise. By having this formula, uh, you can find out the estimation of your that is expected value. It means it is known as a mean squared error. It is also one of the technique in parameter estimation and how you can visualize the trade-off. So the first thing is high bias, low variance. So second thing is so this is low bias, high variance, low bias. These two situation occurs means so the noise will be remain constant. It cannot be reduced. And then and there we have completed the first session. So in afternoon session, or is there any coordinators from pencil bits is there?
Yes, ma'am.
Um, Actually, the first in this module, the second session will be dealing with more and more topics. Shall I cover the half of the in morning itself?
Okay, ma'am. Okay, ma'am.
Okay. Okay. The next thing we are going to see about detail about support vector mission. So I will give a general introduction of the support vector missions and what is the maximum margin hyperplanes and mathematics behind the maximum margin classifications. And after that, in afternoon session, we will be seeing the what is the soft margin SVM classifier and and the topics apart from it. So I will share. Support missions. Is my PPT is visible to all?
Yes, ma'am.
Okay. So this support vector mission, it is widely used powerful supervised learning model for if you are dealing with a classification task, you can go for an SBM. So what is idea behind it means it is used to find a maximum margin hyperplane that um, separating the classes in the feature space and leading to a classifier that generates well on a unlabeled data. So this SVM is also dealing with unlabeled data only. So this is a supervised learning model. As I said, it is used for a classification and regression task, and it finds the optimal hyperplane that best separates the data into different classes. So if you are going for an image classification or a text classification or a bioinformatics kind of thing, you can go for an SVM classifier. So this is an example for SVM classifier. This plane, uh, so this is a hyperplane. So it will classify the data based on the classes. So it usually classifies the data into three types. So based on the hyperplane technique. So it will be having X plane, Y plane, and Z plane. So this is in correspondence with X and Y axis. So why we are going for an SVM? It is very effective in high dimensional spaces. It means if you are dealing with a large number of data sets for classification, so this SVM classifier is very effective, and it is particularly very useful when number of dimensions exceeds the number of samples. So if you are using number of samples and while you are going above 2D or 3D dimensions, this SVM classifier will work based on number of dimensions you are going to classify. So it can be suitable for 4 dimensional and it goes on. It It works well for both linear and nonlinear classification tasks. And linear classification is here. So what does a linear classification means? It will work on two-dimensional data classifications only. It will not deal with more than two-dimensional data classifications. It means it will be having one decision boundary that is called as hyperplane here, that maximizes the margin between the cases. So what is the hyperplane? I have shown three-dimensional data hyperplane. A two-dimensional data hyperplane will look like a linear regression model, a flat line that divides the data points into two classes. That is a linear classification. So see here, this will be looking like a linear regression model only, that is linear classification model only. It means it will be dividing the data into two planes. One is an x plane and y plane. Here it represents a w plane and x plane. So maximum margin hyperplane means, so in binary classification problem, let us assume we have more than two classes. We want to find a hyperplane that separates with the maximum possible margin means, we can go for a MMH, that is called as a MMH. And what is the key concept behind here is a larger margin that results in better generalization of a model. It means that, uh, what are the key concepts? One thing is hyperplane, and second thing is a maximum margin, and third thing is support vectors. So consider a hyperplane with an n-dimensional space. You can represent it as like this, same thing. That is w into x plus b equal to 0. You can represent like this. This is the normal vector. So in terms of vector only, this hyperplane is going to define. So hyperplane, it means that it is a decision boundary. So see here, this is your hyperplane. This is, it means that this will be considered as a decision boundary that separates the points belonging to the different classes. So maximum margin means a distance between the hyperplane. This is the hyper. This is the margin. These dotted lines are represented as a margin. And support vectors means it is a data points that lie closest to the hyperplane that are used to define the maximum margins. An equation of hyperplane I have explained before, where W vector, it is a normal vector, X is a feature vector, and B is a bias term. While you're taking the dot product between these vectors and adding to the bias, it should be always 0. And there are two types of classes, can be positive and negative classes. So while you're taking for a positive classes, it can be plus or plus 1, and for negative classes, it can be a minus 1. So if this is not equal to 0, if this value is greater than or equal to 1 means, so it can be mm, a positive class. So if it is lesser than minus 1 means it can be a negative class. So uh, for optimizing, while you are getting the plus and minus values, you can go for like Lagrange dual formulation. Yes, like you can go for Lagrange dual formulation. It means that if it is dealing with greater than or lesser than or equal to 0, you can go for Lagrange dual formulation. So it is purely dealing with these kind of derivatives other than the 0. And what is decision boundary we have seen, and what are the and it is purely dealing with two types of kernels. One is a linear kernel and also a polynomial kernel. Linear kernel is for two exact points, that is x and y axis points, and polynomial kernel will be dealing with the kind of polynomial distribution problems. How can we solve these kind of kernels occurs that we are going to see in the afternoon session? Hope you are clear with what is SVM and how you are going to classify the points based on SVM is up to that we have seen. So remaining things we will see in the afternoon session in detail. Any doubts in this? Any doubts? You can unmute your mic and all, or you can ask through your chat box. Coordinated, ma'am. Shall we wind up?
Ma'am, it is audible, ma'am.
Yeah.
Thank you so much for your participation. We can have the afternoon by 2 o'clock.
By 2 o'clock,
It was great.
uh, your voice is breaking. By 2 p.m., the afternoon session will be starting out.
Start your afternoon by 2 p.m.
Okay. Okay. Thank you, everyone, and thank you, Pencil Bits, for your wonderful opportunity. And thank you, participants, for hearing my lecture patiently. Thank you. Thank you, everyone.